going to be looking at Olbers' paradox. The universe was first thought to be uniform, infinite, and static. So that is, it was neither contracting nor expanding. And an infinite and static universe is consistent with Newton's law of gravitation, because for a static universe, the overall force acting on all the contents inside the universe would be zero. So for F to be zero, R must be approaching infinity. Olbers argued that if the universe was infinite and uniform, then it would be filled with an infinite number of stars, so all lines of sight will always end on a star. So we would have a bright nighttime sky. So for a given direction, the further away a star is, its light intensity that reaches Earth will decrease, but the number of stars will increase so that the overall intensity remains the same. So the brightness of the sky at night and during the day will always be the same. And as this is not the case, Olbers argued that the universe cannot be finite. So beyond the universe, stars and galaxies do not exist. So many lines of sight reach this darkness, and that's why we have a dark nighttime sky. Also, for a finite universe, there'll be a finite number of stars, and so the total energy from these stars would be too little to make a bright nighttime sky. So there's lots of evidence that the universe isn't static, it's expanding, and so it's not infinite, but has a finite size. So for an expanding universe, the age of the universe is finite. The light may have not had enough time to reach Earth, and that's why we have a dark nighttime sky. Also, the expansion of space causes a cosmological redshift. That means the wavelength of light will increase. The wavelength has stretched as space has expanded. And as a result, the light energy will decrease, so it will be too dim to have a bright nighttime sky.